Welcome back to chemistry. I know it's been a while for most of you. We haven't, you've had a couple weeks to just hopefully maybe let all of this sink in or whatever. When we last had class here, I kind of said we went through that empirical formula stuff, and I said that's kind of it for the chapter. Like that's kind of we're done. I'm a little I have some going through some kind of creative ideas about how we're going to assess. We may be using some video conferencing through Zoom in order to maintain some integrity with assessments. This is a college course. I'm still kind of waiting, honestly, at the time of this video, waiting from some word, waiting on some word from CLC, a little bit of direction here. I have some ideas, but I'm not going to go into a lot of detail right now. But what I thought would really be good right now, I'm going to give you a review worksheet, and I'm just going to go through some examples of each process that we talked about. This was a long chapter with a lot of math, okay? So I am going to post a kind of a review sheet that has a little bit of everything, but I'm just going to go through these basic concepts. Any assessments that we do, I do want to just say, any assessments that we do for this unit, I'm going to let you use this little cheat sheet. And I know all along I've said absolutely not, and some of you are totally fine with that, and some of you are struggling. And I just think, and I've kind of shared with you, some years I let students use that, some years I don't. I think given kind of the added dimension of we're going to be working at home on this at least for quite some time, I'm just going to throw that out the window. You may use this document on any assessments that I give you. So I will post a single sheet of that you can print so that you have a hard copy of just this single sheet. You may use that on assessments. And always periodic tables may be used on assessments, your ion sheet. So please make sure you still have all of those things. We will be using those from now to the end of the year. Assessments are going to look very different. I know that. We just kind of got to see how this goes, and we'll make adjustments where we need to. But let's get back to chemistry. Let's get back to learning. Let's get back to preparing you for college and your careers after high school. So this is a really important concept. This entire chapter is full of important concepts that I want to make sure that we really do have a grasp on. So I guess a little of this is on you, whether you do your own work or not, but just know it's your education and your learning, and that kind of has to be up to you. So please, I expect you to maintain, classroom with your integrity with your work and so on. Please know that what really is important in this course is your learning. What did you learn? Okay, it's not about getting the A, it's about learning the material. Okay, so I think for a lot of you who are struggling, this is just going to make things simpler. Remember, if we're these conversions from whether we're going from mass to moles or mass to particles, you can simply follow these arrows. And remember, as always, everything goes through moles. The magic mole, everything goes through moles. I can't go from grams to particles, or that mass to particles, without converting to moles first. And likewise, I can't go from the mass of a gas to the volume without converting to moles first. So that means I have to use this molar mass conversion anytime. There's a few of you, I think, that have really gotten kind of sloppy with labeling. I don't tell you to label things because I'm mean. I tell you to label things because it really helps you set up the equations. So, and here's an example. So let's say I want to solve the problem, how many grams of H2O are in 1.7 times 10 to the 18th molecules. So I'm going to make a quick little path here. I'm going from molecules to grams. Going from molecules to grams. So I'm starting here. I'm going to convert. I have to go through moles, and then I'm not done. I have to get all the way to grams. Okay? So I'm going to use this conversion factor because I'm following my little arrow, this conversion factor, and then I'm going to use this conversion factor. Molar mass, remember where we're going to find that. That's going to be on that periodic table. So I'm going to just get rid of these arrows because they take up a lot of space, and I'm going to write this out. Let me see, 1.7 times 10 to the 18th. My first conversion factor is this one. This is molecules. Particles are molecules, right? So because I label these, remember my first step here is going to be, I'm starting with molecules. How do I get rid of molecules? Well, my first conversion factor is going to be molecules have to go on the bottom. So here's how this helps me. Do not solve it right here. We're not done yet. But if I did solve right here, I'm left with moles. But I don't want moles. I want grams. So I have to now go through this conversion factor. I got to find the molar mass, right? So H2O, I'm just going to, let me see, that's 2 hydrogen, 1 oxygen, 1 times 2 is 2, because hydrogen has a molar mass of 1, oxygen is 16, 18. Remember what that 18 means? That's how many grams are in 1 mole. I want moles to go away. Moles goes on the bottom. This is why it's important to label, because I have if I'm like struggling, like I don't know what my next conversion factor is, well, it's whatever. I got to find one that gets rid of moles, right? Don't forget when you find that molar mass, that's what this means. It is how many grams are in 1 mole. That's actually what it is. All right, so when you solve this, do not forget, we have to use our parentheses. This is a really large number. It's in scientific notation. If I don't put parentheses around this, my calculator doesn't understand that I'm actually not taking 1.7 times this times 1 times 18 and then dividing it. If I don't put parentheses around this, it's going to think I'm taking 18 divided by 6.02 and then timesing that whole answer by 10 to the 23rd, which is really not what you're doing. So don't forget your parentheses here. Please, you pause this and do a quick check on your calculator to make sure that you get the same answer I do. All right, and remember, you're taking everything on top, the 1.7 times 10 to the 18th times 1 times 18, taking that whole number divided by the bottom, which is Avogadro's number times 1, and that's how you get your answer. And then always evaluate your answer. Does that seem reasonable? Well, based on what we know about scientific notation from several chapters ago, if it's division, we take this 18 exponent minus the 23, so the fact that I got a -5, yeah, that seems pretty reasonable, so I'm going to go with that. Okay, so let's do another example. Whoops, I didn't like that. Let's go with, what is the volume of 125 grams of CO2? All right, so now I want to know the volume. So even though it doesn't say CO2 gas, I really need to assume that, yep, this is actually CO2 gas. I want to know the volume. That's going to be in liters. This is always in liters, and I would know that if I looked at this conversion factor, liters per moles. So my path, I'm starting with grams of CO2. And I want to end up with liters, that volume. So here's my path. Starting with grams, I'm right here, grams, I'm going to do this molar mass conversion to get to moles. And then I'm going to do another, whoops, wrong way. I ran off the road there. Going to do another conversion factor that's going to get me to liters. So let's set this up. If you want to pause this here and set this up, I think that would be really good practice for you. I'm going to go with it. Grams of CO2. I need to find, I know I want grams to go away. I want grams to go on the bottom. My conversion factor here says it's moles over the molar mass, which is in grams. I need to find the molar mass of CO2. So I looked at the periodic table to figure that one out. If I stopped right here and solved this, this would give me the answer in moles. I don't want you to stop and solve halfway through because we're big people and we can do this all in one big long equation. So that's our goal. This is my first conversion factor. This would leave me at moles. That's not where I want to be. I want to be volume, which is liters. So I'm going to do this simple little conversion factor right here. My 22.4 liters. Now, if you want to pause here and calculate this to see if you get the right answer, make sure, whoopsie, I forgot to put my, sorry, this is 125. I didn't even write that in there. 125. Oh, sorry about that. Sorry if that caused you grief or confusion in any way. You can pause here and solve. Okay, so this is the answer I came up with. I took 125. Remember, we're going to multiply everything on top. 125 times 1 times 22.4. Then I take that answer, everything multiplied together, take that answer, divided by everything on the bottom, which is 44 times 1, and that will give me my answer. Hopefully that helped. All right, then I'm just going to do a couple more quick examples using this, the moles per liters, that volume of a gas. Remember, this is only at standard temperature and pressure. But we can use this if we know the density of a gas. We can use it to find the molar mass. If we know the molar mass, we can use it to find the density. So I'm going to write a problem really quickly. All right, so here's my question. What is the molar mass of a gas with the density of 0.95 grams per liter? So the first thing I think that's alarming sometimes for students is, oh my gosh, I don't even know what gas this is. Well, guess what? It doesn't even matter. One thing you should always remember, though, is that when we talk about density, so the density of a gas is expressed in grams per liter. That's different than liquids and solids. Solids are grams per cubic centimeter. Liquids are grams per milliliter. A liter is 1,000 times bigger than a milliliter, a larger amount. But we use liters with gas because, remember, those particles are super spread out. So how do I want to set this up? I think it helps when we're doing these. So I'm going to use either this or this, right? Which way do I need to use it? So I need to think really quickly, what is the molar mass expressed in? So molar mass is in grams per mole. So I want to end up with grams per mole. So I'm going to set this up just starting with what I have here. But I know I want to get rid of, oopsie, sorry, I wrote that wrong. It should be grams per liter, right? So this is grams per liter, not grams per mole, but I want to end up with grams per mole. So I want liters to go away. Now we kind of typically say in these molar conversions that whatever you want to keep should go on top, but the truth is everything that's diagonal from each other is going to cancel out. So if I want liters to go away, I want to use it this way. Oopsie, it's 22.4, sorry. 22, right on here. 0.4, sorry, that's super messy. Okay, so if I calculate that out, I end up with grams. So liters has canceled out. I'm left with grams per mole.